Geotrig, this is lesson 41, day 2. Technically day 3, but day 2 video. We're going to talk about permutation notation. Permutations, guys, are taking things out of a group. So randomly reaching into a basket to grab something out. Choosing people for a team. So like we got about 30 people in our classroom. If I only get to choose 5 of you, how many different combinations or permutations can I have?
So how many kids do we have?
Okay, so this is what we need to do. So I'm going to ask you a question. We could change this a little bit and say there's instead of 22 things in something, there's 22 people, okay? But it says how many permutations are there of 22 things taken 6 at a time? Which means I only am allowed to take 6 of the 22. How this works is that I am going to write down 6 spaces that will represent the thing that I'm taking. And each space has how many people you can choose from, or things. The first one is 22, because there are 22 things originally there. But as soon as you take it, is there still 22 things left? No, there's only 21. And then there becomes 20, 19, 18, 17. And what you can do, guys, is you multiply the number of things that you can choose from together, and that will tell you how many different permutations there are of groups of 6. So if there are 22 people in this room, and I formed a group of 6 people, we would come up with, take your calculator and multiply 22 times 21 times 20 times 19 times 18 times 17. You will have how many ways we could form that group? That's a lot. What do we end up with? We end up with over 53 million permutations. You multiply them all together. Now, no. It could change. We could take only 3 at a time. You can't take 27 because there's only 22 things. If there was 30 things, then you could take 27. You could take all 30. Now, what this means, though, yes, this seems like a lot. Because it is. But you've also got to remember that in this position, Bob can be picked. He's 1 out of 22. There's 22 people. You picked Bob. So Bob's not in the group, but now you can pick Sue. But the thing is, you could reverse things, and Bob could be anywhere in one of these choices. So that's why there's so many of them. There's no replacement. We're not putting people or things back in. So, what if we took the numbers away and talked about just having letters? We talked about having n things. We don't know how many there are. There's just n of them. And you're taking them r at a time. Well, think of this. If I went here, the first one stands for the n value. There's 22 things. We took 6 at a time. So we took 6 of them. But what's 22 minus 6? It's 16. But we end at 7. It's because the first step, even before we move, is already taken a spot, right? The very first number is one of our spots. Then you start subtracting 1. So when we get down here, n is our first thing we're taking. That's how many choices there are. There are n choices in the beginning. Then there becomes n minus 1, then n minus 2, ... to n minus r, because you're taking r of them. But you forget that you have to add 1 back because of the very first choice does not count. Now wait a minute. How many people went to that problem and went 22 times 21 times 20 times 19 times 18 times 17 on their calculator?
Yeah.
Lesson 42.
This is lesson 41.
I did that for sure.
Why didn't you use the shortcut method that we learned
Because that's how
before?
we've been taught.
What was the shortcut method to get that answer of 53 million? What was it? Explanation point, yeah. Isn't that just 22 factorial over 16 factorial? Couldn't you do that instead? Because it's 16. Because what's the number that's missing after 17? 16 factorial. And then if I multiply the top by 16 factorial, I have to multiply the bottom by 16 factorial. Those technically would be multiplying by 1. So I get 22 factorial divided by 16 factorial, which leads you to 53,721,360. Cool. So, we're going to have this thing called permutation notation. And permutation notation looks like this. It just basically says how many permutations of n things taken are at a time. So n, p, r. And when you do that, you're setting up this. You're setting up that factorial thing. And that factorial thing is just n factorial divided by n minus r factorial. Boom. It is on your calculator. Some calculators will have this notation. You can actually just put it right in. But if not, it's really easy to default to how many things you're taking, factorial, and divide it by how many things you're taking minus how many you took, factorial. Okay. So, if I want you guys to tell me how many permutations there are of 12 things taken 4 at a time, can you do that for me? How about 6 things taken 6 at a time? 21 things taken 3 at a time. I want you guys to use permutation notation and then use your calculator if you have to, but I want to see it set up. What should this look like, that first one? What's the setup? 12 factorial over 12 minus 4 factorial. 12 factorial over 8 factorial. I think you guys should be able to handle that without a calculator. It's just 12 times, bless you, 9 times, or 12 times 11 times 10 times 9. 11,880. No, I have someone next to me actually giving me answers, so.
Oh, do you?
Yes.
Little guy in your head?
No, someone actually doing the work with us here in class. Okay. Next one.
I forgot how to do.
I think it's under math.
I know I looked under math.
Yeah, it's under, yes. It's a one, over 1 menu.
Yeah, I know.
I think it's under 5 or under 3. It's your second menu.
I know.
Guys, next one. Isn't that 6 factorial over 6 minus 6 factorial? 6 factorial over 0 factorial? Wait. What is what's 0 factorial?
It's 0. 1.
It's 1. So it actually comes out to just 6 factorial, which is
Hold on.
720. Last one. 21 factorial over, or 3 factorial 21 factorial over 18 factorial. Not as big of a number as you think it would be, because you're only taking three things. 7,980. So, I realize, guys, that we skipped over the lesson that actually dealt with the permutation itself originally before we get to the permutation notation. So I'm going to give you the definition of why in these problems that if you have 12 things, listen please, that you have 12 things and you're taking 4 of them at a time, why is there 11,880 permutations? It's because a permutation, guys, is when you are able to take 4 things and rearrange those 4 things in any order. So, an example for a permutation, guys. You have the letters A, B, and C. A, B, C itself in that order is one permutation of 3 things.
Well, then you can do B, A, C.
Then you can do A, C, B. You can do B, A, C or B, C, A. You can do
C, A, B.
C, A,
You
B,
can do C, B, A.
C, B, A. Anything else?
And that's it. That's all you can do.
Okay. So if you have 3 things,
You can have 6.
taken 3 at a time, according to permutation notation, then this be 3p3?
Yes.
Which means it would be 3 factorial over 0 factorial,
Or 1.
or 1.
So it's
And what's 3
times
factorial?
2 times 1,
Which is
6.
6. How many different ways was there?
6.
There were 6 different ways to take those 3 things. Now, listen. How did we end up with 11,000? Or back here, how did you end up with 53,000 or 53 million different ways? It's because if we're taking a group like this classroom of 22 things or larger, and I'm randomly selecting 6 people, not only do those 6 people be able to be moved around, I can swap out the 6 for another 6 and they get to move around. That's a big number. That means we have 53 different ways I can rearrange you guys in groups of 6. That's crazy. Think of your lock on your locker. How many numbers are on that lock? 30. I think there's, is it, there gotta be, I thought it was 30. I thought there was like 36 or something, or 40. I don't know. Well, let's just say 40, right? You only have 3 numbers on that 40, guys. There's 60, okay. 60 numbers. 3 at a time. Guys, we're not arguing about this anymore. 60 numbers taken 3 at a time. How many different combinations for your school lock can be made? 60 factorial over 57 factorial. What do you end up with? 4.89 times 10 to the
48th power.
So that would be 59 times 58 times 57, right?
Yeah, that would be right. That just seems like a little big number. You divide that by 57 factorial? Something? Okay. Listen, we got to make a correction, guys. Got to make a correction. We put that on the calculator wrong. 60 factorial divided by 57 factorial is 200.
205.
Different ways to put those numbers together. What's the chances if you'll have the same locker comm as someone else in this school? Pretty low.
But it's possible.
It's possible, of course it is. There's only so many combinations, right? So So technically, you just got to try that many combinations, and then therefore you'll have you'll be able to get into someone's body.
That'd be amazing if I did.
Your homework then is the worksheet 2, and finish up worksheet 1.